Let's look at for loops. For loops are great when we know exactly how many times a loop needs to run, or we can find out how many times a loop needs to run. Every time a loop goes through, we call that an iteration. So we're looking here, I'm going to get rid of this word next. That's from Visual Basic. So again, it's very useful when we know how many times a loop has to iterate. One trip through a loop is considered an iteration. So either we know it or we can easily find it out. So back to where we were in our first example for our first for loop. So I'll type FOR, and then we have some parentheses. Now, the first thing we'll have is a variable. I'll call it int counter, and I'll have it equal 0 here at the start. That's an initial value. We could start it at any number. Right now, I'll start at 0. Next argument, notice there's a semicolon after the first one, is the condition. So as long as counter is less than 10, we're going to keep this loop going. And then there's the update. I'm going to use counter plus plus. That's the same thing as counter plus equals 1. It will make the counter go up or increment by 1. I'll show you later that plus equals 1 also works. So again, take a look. Here's the three things inside the parentheses. We initialize a variable, tell it where to start. We have a condition to check. As long as it's true, the loop runs, and then we update the counter. Truthfully, the update counter happens before the condition is checked. We'll see that a lot later in the video. All right. Well, we want to add an item to the list box every time this loop runs. I'll type in woof. And if we start at 0 and go to 10, counting by 1, that's going to be from 0 to 9. That should happen 10 times. I'll label the end of that loop and start the program to see if we get 10 woofs. There they are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, going from 0 to 9. That's what happened to that variable counter. First it was 0, then 1, then 2, then 3. If I click it again, I get more woofs, but the list box didn't clear. So I think it'd be a good idea to add a clear method at the start of this button. So whatever was in the list box is gone. And again, counter will start at 0, then it will be 1, then 2, then 3, then 4, then 5, then 6, then 7, then 8, then 9. It actually does become 10, but because 10 is not less than 10, the loop ends. There's that condition right there. Well, what if we want to have 20 of them in there? Now counter goes from 0 to 19, and we get 20 woofs. Might be kind of hard to tell because they're all the same words. What if we need 100 of them? They happen very quickly. So again, you're seeing how handy this is when you know exactly how many times a loop needs to run. Well, let's get an ending number from the users. So I'll declare a variable called int ending number. And we're going to get that out of the text box that you saw on the form. So I'll use int.tryparse inside this if, try to get a number out of the text box, and then remember to use out. I actually forgot that the first time, so there it is, out ending number. That's where it's going to go if it works. So if it's great, it'll go inside the if. Otherwise, it means they didn't really give us an integer. So if we did get an integer, I'm going to slide this for loop we already wrote inside the if. I'll cut it and paste it. We'll start at 0, but we'll end with the user's ending number. If it's not an integer, we'll generate an error message for the users. You can pause the video and write one yourself. So let's check it out. So if we end with cookies, oh good, our error message worked. Let's end with 112. Oh no, I guess just 12. And there are 12 woofs. I'll show you again that counter plus equals 1 is the same thing. You were more familiar with that before we watched this video. They both work the same way. So I put in 5, there are 5 woofs. Counter goes from 0 to 1 to 2 to 3 to 4. It actually does hit 5, but 5 is not less than 5. That's that test in the middle of counter being less than ending number. Let's actually look at the number for the counter. So we'll put counter in there and we'll watch as this counter variable changes its values every iteration of the loop. So if we want to see 7 numbers, there they are, 0, 1, 2, 3, 4, 5, 6. That's the value of counter each time through the loop because we just displayed it. If you'd rather start with the number 1, we can put a 1 where the 0 is as our initial value. That's the starting value. And remember, that's what that first argument does there. And then maybe we would want to say counter is less than or equal to ending number. We'll actually see the ending number this time. So if I put in a 7, we count 1, 2, 3, 4, 5, 6, 7. That is what the variable counter equals each time through the loop. And so we displayed it. Doesn't take very long to get 900 numbers on there. Let's try 9,000. The loop actually runs very quickly. It's the displaying it into the list box is what took the time. You could start with any number. Again, that's our initial value. So you could choose to start with 24. And then we can have an ending number of 45. And we start at 24 and end at 45. If we use a number that is less than 24 at the start, such as 11, the loop never executes. There's no iterations because 24 is not less than or equal to 11. So it is false right away on the condition to check, so the loop has no iterations. I'll change that back to a 1. Lots of times what we want to do is to count by 1. But what if we want to go up by 2? I'm going to copy a whole bunch of this code here from the first one we did and place it here when we go up by 2. And I need to change some documentation. We're now actually going up by 2. I should have moved that for initialize counter condition to check an update counter, but I didn't do that. But the big change here is plus equals 2. Instead of plus equals 1, plus equals 2. So now if we want to end at 15 and start at 1, you can see that we're counting by 2 every time because that's what happens. If you go to 20, notice it stops. You go to 19, the next value is 21. 21 is not less than 20. So that's why it stops at 19 in the list box. We can begin with the number 2. And now type in 100, count by 2s, because we're adding by 2 every time. Maybe you want to start with 0. And then the value of counter will go up by 2 every time until we hit the ending number, or until we go beyond the ending number, actually. Because truthfully, counter will equal 20, but 20 is not less than or equal to 18, and that's a signal to exit the loop. We can even count backwards. So decrement or decrease by 1. I will copy again a bunch of this code and paste it down here. And again, we want to decrease by -1 or go down by 1. And I'll get this there. There's that 4 comment showing you what's going on with the 4 arguments. And it's going to be minus equals 1. That's the big change. Plus equals 2 goes up by 2. Minus equal 1 goes down by 1. So I will change this to say starting number. That's what they're actually going to put into the text box. I'll make the counter start at starting number, and its counter is greater than or equal to, I'll say 1. That way it's going to end on 1. So really that's a starting number of 50. And we count down from 50 all the way to 1, going down by 1 every time. If we start with 1,200, we count down by 1 every time. You could also use counter minus minus like we used plus plus. That will also work to make the value of counter go down by 1 every time. It's called decrement instead of increment. You don't have to stop at a positive value or at 0. We can go into negative territory too. So I made the condition say that we're going to deal with -200, and we're going to get all the way down to -200. Truthfully, you could actually count with doubles and even count by decimal values. I'm just using integers right now. The variable counter, if I try to look at it outside the loop, Well, there's a red squiggle coming up because the counter does not exist outside the loop. Because it's declared on line 95 in those parentheses, we don't have access to it outside of those braces. That's the scope that it has. It can only be seen inside there. If for some reason you need to see your counter variable outside the loop, declare it before the loop. Then don't redeclare it inside. Just say counter equals in that place. And now I'll use messagebox.show and I'll show you the counter. And we can access it now because the variable was declared outside the loop. I'll type in 50, and notice counter equals 0, even though the last number we would see is 1, because counter will become 0, and 0 is not greater than or equal to 1, and that's how we get out of the loop. We should document a for loop so we know what its purpose is. So the purpose of this for loop is to count backwards by 1 from where the user wants until we get to the number 1. We can go document another one of our for loops. Take that out, and the idea here is to, yes, count or step by 2. We're going up by 2 every time in this loop. Looks like we're starting at 0 until the number that the user is ending with. So it's a good idea that we should, at the top of a loop or at the bottom, explain what the purpose of the loop is. Next, let's get a sum of list box numbers. So I'm going to click on the list box, come over here to items, and click on collection, and then put some numbers in. I'm using 1, 2, 3, 4, 5, and 6. You can use any numbers you want. They do not need to be consecutive integers. I'll switch them later on, and you'll see that that's the case. But I'm putting in 1, 2, 3, 4, 5, and 6. And I want to use a for loop to find the sum of all the values. Well, I'm going to declare a variable that will hold that sum, just like we've done with totals before when we've had restaurants. And then we'll use a for loop to go through or traverse all the values in the list box. Traverse would mean to go through all of them. So I'm going to use x as my counter variable. A lot of times we use x or y or I or j. So I'll say x equals 0, and as long as x is less than the count, so lstanswers.items.count, because x is going to be the actual index. So if there's 10 items in the list box, we want to go all the way from index 0 to index 9. Right now we have 6 items in there. So we start at index 0, 1, 2, 3, 4, 5. The number 6 is actually at index 5. The number 1 is actually at index 0. So that's why I set it up like that. So now sum plus equals, because we're keeping a total, well, int.parse, we have to use that. Then the name of the list box, lstanswer.items, and then we'll use brackets with an x. That's the actual individual item. But then we have to say .toString because the items are actually objects. So to follow this, we have to take an object, convert it to a string, and then parse it into an integer. And then here at the end, we'll show the sum. So if you need to pause the video on that line 128 there, go ahead. But they do all add up to 21. I'll change the numbers and show you that you can use any numbers you want. And they're successfully added up. I'll go back to one of our previous ones. So there's 1 through 10, and they do add up to 55. If we count by 2s, those in fact add up to 30. Every time we have an iteration in the loop, we add the new value to the previous sum. And again, the count, you notice, is always going to be 1 more than the last index, or the last index is always 1 less than the count. That's why we set it up like that. So again, that x inside the brackets on line 128 is the actual index value of each item in the list box, starting with 0 and ending with the last one, which will be count minus 1.